Okay, so what we're going to look at tonight is geometric series and sequences. So remember again, sequence is basically, a pattern of numbers. We put a ... on the end. Series means we sum them all up. Now we have some formulas to sum up arithmetic ones, and we're going to look at geometric ones. So we have already established arithmetic sequences or series have that common difference. So plus 5, plus 5, plus 5, minus 17, minus 17, minus 17. Okay, so those have to have that common difference and they're linear. Here's what geometric is. The ratio of successive terms is always the same non-zero number. So clearly you can't have a ratio that is 0 or nothing's really happening. So basically you divide, the n plus 1 by the nth term, the n plus 2 by the n plus 1, and you get the same ratio. So is it multiplying by 3? Is it multiplying by 1/3? Is it multiplying by 10? Is it, multiplying by 1/7? Whatever it's doing. Okay, and ratios don't always have to be positive. Here's how we express our geometric sequences. So within each sequence, geometric or arithmetic, we can have two different formulas, recursive and explicit. Okay, here's how we find the ratio again. So this is Tn divided by Tn minus 1. That's the exact same thing as saying one term above it divided by the previous term. So however you want to think about it. Okay, you could even say, term 4 divided by term 3. Okay, explicitly, here's what the formula looks like. So we're using t's instead of a's here, but they're all the same thing. So the nth term is the first term times the common ratio raised to the n minus 1. Recursively, we say t sub 1 is the first term, then we say the nth term is just the previous term times the ratio. So again, recursively is easy. First term is 10. The nth term is the previous term times a rate of 4. Okay, but explicitly will let us easily be able to do the 50th term without finding the 49th. We can jump from 1 to 2 right to 50 explicitly. Recursive, we need to count them all out. So I give you guys a simple sequence here. You're realizing it's being multiplied by 2 every time, which is the same thing as 6 over 3 equals 12 over 6 equals 24 over 12. So we've established the r is 2. Grab the first term, throw that right there. The key is it's raised to the n minus 1. And here's why. When you go find the first term, t sub 1, you have to plug a 1 in for n there and there. So what happens is you get 3, 2 to the 0. Anything to a 0 power is just 1. So you're always 1 off with that ratio. So the 11th term would actually be 2 to the 10th and then times 3. Okay? You can see how we did it recursively down here. First term is a 3. You would find the nth term by doing 2 times the previous term. So explicits are probably more where we want to lean for equations. Not everything has to be geometric or arithmetic, so you can have a goofy kind of sequence. We call those neithers. So here's 3 quick examples. You guys can pause it and figure out what you think for these. I'm going to do the same and provide you guys some answers just to save a little time. So you can see first one's geometric, and I just went ahead and gave you a formula for it because it's definitely good practice to come up with those. First term of 3, ratio of 5 to the n minus 1. Next one's a neither. Not saying we can't come up with an equation for this. It's actually more of a quadratic, but it's neither geometric nor arithmetic. Okay, there's no ratio in between these. And last one here is clearly arithmetic. Common difference is -4. So I gave you that equation there. If you went ahead and simplified it, you'd get to this. So we could easily find the 700th term if we desired. So same idea as we did with arithmetic. We want to be able to come up with equations and find the 11th term. So 4, 2, 1, 1/2. You guys can see, what's going to happen with these like this. So clearly it's geometric, not only because it says that, but also because our ratios are all the same. So 2/4 is the same thing as 1/2 is the same thing as 1/2 over 1/4. Don't say the rate is 2. Okay, you need to say the rate is 1/2. So the nth term, 4th term, 1/2 raised to the n minus 1. Okay, and you can easily check that and make sure it works. So if I want to find the 11th term, that's going to be 10, okay, because obviously 10 minus 11 there. So I put two different forms in the calculator here. If you're going to use the 1/2, be real careful. You close those parentheses up before you raise it to the 10th. But anyway, your answer should be 0.039. And if you want, turn that into a fraction. 1/256. Okay, so a lot of questions are going to fall along that similar line there. Next, just like with arithmetic, we could sum all of those up in a sequence or a series. Here's your proof for the first, or formula for the first n terms of a geometric sequence. So if I tell you sum the first 47 terms of this sequence, this is the formula that you need. Feel free to look at the proof in your book. Maybe we'll talk about it some in class. You guys will have this available to you. You just need to know how to use it. Okay, it's kind of neat to see where all this stuff comes from. So S stands for sum. Okay, so sum of n, so the first 12 terms, whatever it is. A we know is always the first term. 1 minus r to the n. Okay, r is the ratio or the rate that thing is growing by, all over 1 minus r. So it's super easy to set up, but solving it can be a little tricky, especially when these ratios are fractions. Okay, notice this r can't be a 0 or a 1, and that just kind of makes sense. We talked about why you can't have a ratio of 0. You can't have a ratio of 1 as well because it's just repeating the same number. Okay, 5, 5, 5, 5, 5. That has a common ratio of 1, so nothing's really happening. Okay, sometimes you may see this formula blocked off like this, because that's really what you want to look at, is evaluate those first, and then it's really easy to multiply by A. Okay, here's an example where it asks you to sum the first 10 terms of the geometric series. So series means we want to actually sum these up. So it says A sub n in brackets there. Okay, it's the exact same thing as, this. Okay, so if you want to sum the first 10, just think about what's happening. First term's 1/5. Okay, the next term would be 1/25, because that n's going to apply there and there. It's not going to change anything with the 1. Third term would be 1/5 cubed, and all the way down until we get t sub 10 is 1/5 to the 10th. Okay, we have a formula here. Sum of n is A, that's our first term, of 1/5. I'm going to use fractions. Sometimes you can use decimals, and it'll help you out. 1 minus that 1/5 to the 10th, all over 1 minus 1/5. Okay, again, they're super easy to get set up. It just takes a little bit to solve these correctly. So I simplified it to there, and if you want, go ahead and try and solve it, plug it in your calculator, and we'll pick up part 2 with how we actually do this.